hi everybody. Welcome to RPC Standards number 7. It is June 23rd. We are being recorded. The agenda has been posted in the chat. This is Ethereum PM issue 1585 for those that don't have access to the chat. We have a number of different things on the agenda. And I think we can just take it from the top and start working through them. So, thanks everybody. The big thing that we want to tackle at the top of the meeting is the Docusaurus versus Gatsby conversation. Has anybody had a chance to form an opinion on the matter? Just to kind of lay things out where we are right now, we have branches that do both. You can take a look at them. The current recommendation from OpenRPC is to go with Gatsby, which is going to be a little bit more future compatible with where their roadmap is going. That may be an oversimplification, but I think that's kind of the gist of it. Let's open the discussion there. Anyone have any thoughts, opinions, concerns?
Well, I'll take a stab since I'm as the one who wrote both the PRs. Probably one of those words anyway. I think I'm down with either. It makes more. I mean, like I will say, the Docusaurus one is much prettier to look at, but I know that the OpenRPC team said that they were going to work towards an update to the visuals, and that's not imperative to the functioning of the docs. And if we can stay with the whatever is maintained, because the Docusaurus one has some documented flaws in that it's old and some of the formatting is broken. So my personal vote would be to go back to the Gatsby stuff. Whether or not my PR is exactly how we want to do it or not, there may be better ways, but it at least gets, if we were to take that one, it would get us up to date with their stuff, and kind of it pulls. I've also updated it so that it pulls in all the narrative documentation that we have and puts it in the sidebar, so it kind of has all that stuff, and it should pick it up automatically as we add new things along the way. So that would be my first opinion.
Awesome. Thank you. Anyone else? Got a thumbs up from Zane? Okay. Mercy's got a thumbs up too. All right.
I will make one more comment that if we do decide we want to move forward with going back to the the Gatsby one, I would appreciate some more feedback kind of on just the way it's set up, and I'm happy to talk through that with anybody who wants to look in detail at it. So I'll just note that there are some hacks. They're not bad, but just the ways that I had to set it up because of the way we generate the Gatsby code. So we don't have to delve into that now. That's just UI kind of stuff.
Okay, so when you say feedback on that, it sounds like kind of build process, how it gets deployed, how it gets built out, things like that. Operational and best practices advice is what you're looking for.
Right, and yeah, and just some opinions about like I said, I'm lazy, so I use AI to help write some of the scripts that migrate our code into the builds. Anyway, it's just like stuff that I'm not a front end guy by trade. I do JavaScript, but I worked on the back end for the last 4 years. So it's just someone with a better nose for that. I know how to do it and not make it look good, given the tools we're working with. If that makes sense. And then also any improvements to the build process, because it's right now a little bit brittle. As soon as we start moving this around, we're going to have to modify these build scripts that I put together to make it work right.
Okay. All right. Do we have any volunteers for that immediately?
Yeah.
Sorry, I didn't quite get the question.
Yeah, go ahead, Mercy, and then Zane.
I did not really understand what he was saying because the background's kind of noisy.
Sure, yeah. Essentially what he was saying is that the build process is a little bit brittle, and he does not feel that he is, a super advanced front-end engineer. And so we could use some advice on the build process, how it gets folded into our development workflow, and how it gets deployed, things like that.
Okay, yeah, I noticed that when I tried running his pair, it's quite it I think the other one was kind of like more straightforward than this, but I don't even have an idea. I think we need
Okay.
to figure that out something.
Okay, so it sounds like you're seeing the same problem that Acolyte was then.
Yeah, building it takes like extra step. Like you have to do run the build, then generate the clients, then build the docs, run npm, run build docs Gatsby, then copy the docs again, and like there's several runs rather than just one command.
Uh-huh.
I don't know what I'm saying. It makes sense. Yeah.
It does. Yep.
Not going to
Gotcha.
spend a ton of time on this call talking about that because it's not specific to this. If everyone's okay with the general idea of going back to OpenRPC, Gatsby build for now. I mean, we can merge this as a first step and then keep working on it because it's not all the time that we're doing this kind of stuff. But it would be good to get it right.
Okay. Sounds like we have a decision. Gatsby it is. Good progress, folks. Okay. Let's see. Are we ready to move on to the next item on the agenda? Going once. Going twice. Okay. 3 times is sold. So, second,
Uh,
go ahead, Mercy.
yeah, I wanted to point out that we have a CI that is failing. I think we have mentioned that on the chat. It would be nice if like clients can like take a look at it because we can't really do anything with the Gatsby migration unless that is being settled because the CI is failing.
Got it. All right. I'll talk to him about that. Yeah, he's not available for this call right now. Okay. Speaking of Matt, he and I had a little bit of a discussion in 2 weeks ago, I think it was, and we were talking about the idea of, how do we actually validate requests that need to be compliant with the spec, right? So, for instance, right now, our testing process, and this is an oversimplification, is basically write some requests by hand, run them against Geth, and see that the response is what you expect. There is a missing piece of the equation here specific to the requests, right? So if you roll a request by hand and you introduce a bug and Geth doesn't recognize it and it still answers back with a response, you've kind of missed some test coverage, right? So I think the discussion that I'd like to have right now is like, how are we actually validating that requests being made to the client are spec compliant? Mercy, you got your hand up. Go ahead.
Yeah, so currently I was working on a kind of like a CLI that validates the IO request arguments like against the derived schemas from the OpenRCB spec itself. So it kind of like raises errors when the structure doesn't match what the spec. Not we are not like relying on get anymore. So it's kind of like something I'm working on. I need to share the docs with you so that you can take a look at it. I
That's
started
awesome.
that last week. Yeah.
That's exactly what I was
Yeah,
hoping to
it's
discuss.
more like a pre-validation layer. It doesn't like depend on any client. It checks the spec on what the spec says, not on what get is saying.
This is huge. All right, so I'm gonna make a little note here. Mercy is working on a pre-validation is what you called it?
Yes.
Can you say a little bit more about where it lives and where it gets run? Is this being run as part of generating the tests, like through the test fillers, or is this being run on as part of the Hive RPC compat tests?
Yeah, okay. The I kind of like I'm trying to make it a standalone tool for now, and then we can gently after I kind of like build out a small part of it, we can then migrate to doing it the compact or into Hive.
Okay, cool. It looks like Zane has a tool already in mind.
Oh,
Posted it. He just posted in the chat here.
Oh yeah,
Zane.
this one that Zane linked is more like I'd say like an alternative to the Hive testing where it's gonna hit the actual endpoint. But I think one thing that I see as like a disconnect between the spec and the Hive tests is that um, for example, this test coverage tool would use examples from the spec, right, as the requests instead of having to like I'm sure in some cases you would want to override those. And I've done that in a couple of projects where I just override specific things when I run the test coverage. But yeah, I just want to point out that there is like a discrepancy there still between like we have examples in the spec, but we don't use a lot of them in the Hive tests.
Hmm.
Like the spec itself has example requests and example responses. And then we're kind of duplicating that again into Hive in some cases.
so
Right.
okay, sorry, I don't really understand. Like, does this particular tool does it like passes the .io test files from the execution APIs and then validates only the request portion, like against the JSON schema derived from the OpenRC specification?
Like I said, this is different from the Hive tooling and these .io files, right? It uses the example requests and responses that are inside the OpenRPC spec itself.
Okay.
So yeah, I just want to point out that there's a discrepancy right now where we have examples in the execution APIs, right? There's tons of them in there and they're great, but we don't actually use those or test them or anything. We have this separate Hive.io files that we may or may not, generate from the spec, but
Sorry, I've got a very clicky keyboard, but I'm just making some notes here. That is kind of a disconnect that, yeah, I highlighted on the agenda, right? Like, is this a feature or a bug? When you sit down to write a test, I would assume that you would want that to be validated structurally against the spec right off the bat. Does anyone have any arguments against that?
That makes sense to me. That sounds like what Mercy's already built or working on, right? I mean, it's you produce requests, and then whatever JSON that you would send to a client, like you're validating those requests to match the spec, based on its, whatever it's the right number of parameters and their hex strings, 0x prefix hex strings or booleans or whatever they are. I mean, that's the idea, right?
Yeah, and I think it's as simple. I think it's as simple as running the first line of the .io files through a JSON schema or the spec validator, whatever this thing is
Right.
that manifests to make sure that you're in compliance.
Right. Yeah, and then one step further from that would be to generate. Well, this is what step on. Like kind of do like a fuzzing where like against an actual endpoint where you generate real and fake data. And maybe that's more what the OpenRPC test coverage thing is. Where is that what it's doing? Is it just testing to verify that?
So I think, well, what the OpenRPC test coverage does is think of it as like instead of this Hive thing, right? We already have requests and responses in the spec itself. So it just runs over there, makes a request, does it get the same response? And then there's things like you can make it a bit, like you said, a bit more fuzzy where it's like, okay, it doesn't have to match exactly, but what if it matches the schema that you get back, right? Or maybe the request matches that or whatever, right? Um, but I think to it's fine if we keep the like Hive and .io stuff. I think that stuff is good, but I think I'm just pointing out that there is a little gap that I think we can close with a bit of tooling there, which is maybe this exists already, maybe I missed it, but would be like have something that just rips through, looks at the example requests and responses that are in the spec already, and then generate .io files, instead of writing them by hand. I'm sure like we'll obviously want to
Um,
write some by
so,
hand, but I just
okay,
right.
sorry. The .io files are not written by hand. They are like auto-generated from the generator.go file.
Yeah.
Okay,
Yeah.
and it's
Yeah.
generated
So the
from a
gen
They're not
Golang file.
no, they're not written by hand. You generate it from the RPC test gen repo, and then you kind of like the two repo talk to, I think they kind of like have a communication link. They talk to each other because whatever test you're writing on the generator.go from the RPC test gen repo, you kind of like generate .io files. You don't input it by hand. It's automatically generated. It uses this command. Let me get the command.
Okay, so is it generated now from, does that use the spec to generate it? Like it does use the examples today? Or I thought you were saying you had to, I thought at the beginning we were saying we had to write these um, IO files, right?
No, we don't like write it like the way we normally write. You don't manually do it. It's auto-generated from the code you've written.
Yeah.
Okay, so can you link to like some example test that's in Go?
Yeah, it's in the execution APIs thing. This is a step of the process that we call test filling, right? And essentially what it means is that you set up a client like Geth, you import a blockchain, and then you run some tests, some Go code like what Mercy has linked to here, and that code generates the requests and executes them against the client and then saves the response, and that's your IO file. Did I describe that accurately, Mercy?
Yes, yes.
Okay, okay. So yeah, I think, like I said, we could do something that, similar to this where we could also look through the existing examples that we have, right? And generate IO stuff from that, right? So that we can close the gap on whatever examples
Yeah.
are missing. Or if we don't want that particular example, then at least we can uh, kind of like document that.
Yeah, I think that makes sense. I mean, you could take the Go code right there has the request baked into it somehow, right? Like it knows what parameters you need to provide to the call being tested in order to get a response. And so maybe we get those from the examples instead. I guess what's the argument for changing that?
I'm not saying change anything. I'm just saying in addition to all of our
Okay.
existing IO files, it would be great to like make use out of the stuff that we have in the execution APIs specs already, right? Which is we have some examples in there. If those are useful, we should try and use them. That's all I'm saying.
Yeah, I think that's kind of what we're trying to figure out is how are they useful? And today they're not necessarily useful in our testing pipeline. So we would have to change that testing pipeline to make them useful.
Right. Okay. Uh, so maybe, yeah, maybe we can work on the testing pipeline. Like for example, um, like we could do the same thing with IO and not have to write like this execution APIs tests ETH estimate gas, right? Like we know how to call ETH estimate gas. We have a whole thing on it, and we know every method that we should be calling, right? Like there's like obviously some tooling improvements we can do here where we don't have to write. Like if you add a new method to the spec, we shouldn't have to add a new test, right? Like we know how to call, that's why we spec'd it out.
Right, right, right.
So I don't know how we get there from here. I'm just saying that the that there's lots of improvements to be made there, maybe not just the examples, right?
And just to recap, just to make sure that I have everything like clear myself. So currently RPC test gen is used to then generate the .io files that then get merged into the execution APIs. And then that becomes the
Yeah.
way that you go about testing the spec. And the step that you're suggesting that is missing is that maybe sometimes the request that comes from RPC test gen doesn't actually validate against the spec itself. So like RPC test gen sometimes may not be calling the, might not be in adherence to the spec itself.
That's okay. Let me just I think there's kind of like a misconception or misunderstanding on what the problem is. So the issue we have here is that the test contributors currently depend on running their .io files against get. So to discover any form of malformed request. So this like introduces a kind of like everything has to be on get. If get says like we need to wait on get in order to run any test. You can't like do it stand as a standalone run. So like we want to like reconnect test generation to the spec itself, not to clients, like not to make it based on a particular or a specific client. By validating the request structure directly using schema derived from the OpenRC YAML. I don't know what I'm saying is making sense.
It does, it does, and that's kind of a known issue. I think we can keep things a little bit more narrower and just focus on making sure that the requests actually are covered by the spec, because I think that's the one thing that's clearly a miss right now, right? Because you could still make an argument that like, well, Geth is the reference implementation, and so, you know, whether or not it is a requirement for creating new RPC calls and validating them and testing them is still potentially up for debate, I think. I agree. I personally think that it shouldn't be, but there's arguments either way. Okay, so this is good. So we have some action items here. We're going to take a look at the RPC test gen. We're going to figure out, okay, where does the requests come from? How are they generated? Would it make more sense to draw them from the actual examples in the spec and then also execute, spec validation against what is generated?
Yeah, I
Yeah.
think just looking at any like like I said, I think the IO stuff we have in there is okay. I think we could maybe close some gaps with how we're like generating these on the RPC test gen side. I need to look into that repo a little bit more on where
Awesome.
yeah, the Golang side of how they're generated, but yeah, I think this is actually like a good pipeline of like ending up with the .io files, because if we were just doing, say, like using the test coverage tool, it would basically just give you like whether or not it was valid when you're like calling Geth, which is great, but this like pipeline where we have the IO files after is just like obviously a lot more flexible, right? Because you can run it in like 2 stages. So I think that's pretty cool. And then, yeah, it would be great to see how we can leverage just more of what we have in the spec to help the tooling along.
Okay.
That's my summary.
Awesome. 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 Mercy, does this align with what you were talking about earlier? What you were working on?
Yeah. Yes.
Okay. Okay. I like the sounds of this. So what we could do then is would it make sense for us to open an issue against the execution API repo, collect these thoughts, right? And then maybe just put a couple of, put an outline in an issue that says, hey, here's where we think we want to adjust this pipeline to incorporate validation of the OpenRPC specs for it. I think that would give us a very clear, it's almost like an engineering notebook that says, hey, here's the problem that we're going to solve. Here's where in the code we think we need to update it, and here's what it's going to buy us. And then that could be a thing that we discuss more broadly in the community. Does that make sense?
Yeah, it does.
Would Mercy and Shane, would you two mind, maybe pairing on something like that and then opening that against the repo, and then I can run it by Matt and the rest of the community?
Okay.
Yeah, I'm gonna dive into this RPC test gen repo and see, yeah, just see where we can make some, yeah, because I'm looking I'm looking at that generators go file. So I think we can come up with something that helps us manage that over time. I don't know if you saw it, it's a crazy file.
Yeah.
Yeah, and it's the code is crazy also.
Yeah. So yeah, I think yeah, I'm gonna look a lot more into this, but yeah, I'm gonna think about this, and we gotta be able to come up with something to help us cut down on some of that.
Huge.
Yeah,
This is
cool.
huge. Thank you. Thank you so much. All right. Cool. All right. So we're at the halfway point here. We do have some other things on the agenda here. I want to move on to our style guide. I'd like to have a regular conversation about what goes into a style guide for new developers, and what is the guidance that we can give them, and how do we express that guidance in the spec itself. One of the problems that we have, and I think there's a little bit of inconsistency throughout the RPC itself as to how you handle some things. We've talked about error reporting in the past. Folks have opened up suggestions for grouping the errors. We have talked a lot about being agnostic on the messaging for errors, et cetera, et cetera. Those are aspects of API design that we need to put a narrative around and include in the documentation for developers to use. One thing that I have discovered is the way that we handle search results. Okay, sometimes you return a 200, specifically empty search results. I'm sorry, I should clarify that. So if you make an API call that's essentially a search and nothing is found, is it a 200 with a null response? Is it a 200 with an empty array response? Or is it a OpenRPC minus 3200 not found? Okay, these are all different ways to do that. And I think that there is probably some editorial advice we can give people as to why you would use one or another. My question to the group, though, is what is the best way to find these inconsistencies across the spec and then try to align them? Simpson, I see you piped in the chat. Would you like to say more?
No, whatever you said is exactly right. We've noticed different clients, different chain returning all sorts of formats for these search results, and the clients or the downstreaming apps have to do multiple validations logic to get around that. So yeah, it would be great to get that also standardized. It's just agreeing with your point.
Okay, cool, thank you. Does anyone have any suggestions on how we can find all of these places where this is an issue?
Is it possible to like extend Hive to write a script that loads the result adjusted then from the test output, matches return format against known good expectation actually?
And like all of our tests right now are successes, right? We don't have any error tests. Or did you add some on the did we add that in your PR for error codes yet? Or
Mm, not the test yet, but I've been meaning to.
yeah, I think that's something we should look at is like seeing how we can adapt RPC test gen and Hive to deal with errors. Maybe Hive already does, but it doesn't seem like we do much in our current RPC test gen for that right now.
So what's curious though is that an empty search is not necessarily an error. Like in some cases, it may be handled as an error. The question is that correct, right? And how do we find these discrepancies? Because I think what we want to do is we want to get to a world where we say, here's the guidance on how to, respond to a search. And in some cases, a null is appropriate. In other cases, an empty list is appropriate. And in other cases, it is in fact an error state because the thing that you were looking for should be there. And that's a problem. Like if I'm looking for, a block that I know has been finalized, right? That could be that maybe that should be more extreme of a response than an empty array or null.
Yeah. Do we have
Yeah.
like an R something that is like a linter tool? That would be nice. But it's if we have something that works as an RPC response linter to that, when we run the tool, we kind of like have when we run the .io test cases, for example, then we pass the results, flag methods that return inconsistency results for empty states. E.g., I don't know. I'm just thinking out loud though.
Yeah, okay, so a linter, got it.
I guess, well, I guess conceptually, like, I guess the real question is, at what point does the client decide to like draw the line, and at what point does the like producer like communicate that? Like you said, like given the state of the data, you should be getting back not an empty array. And so, and in terms of like the final state block that we were talking about as an example, and the request itself is valid, but the data itself is invalid is kind of that like tension point that you're talking about. And the question is how proactive should the the execution APIs or the execution engines be about telling the user that there's like a potential problem? But I think maybe the thing to do there is, unless it's like something that is explicitly an error, it's kind of hard to code for consuming application like sort of state issues. So it's kind of like maybe internally the client has a bug, but when you like maybe the response is to just always return back the empty array. And then if it's like, hey, look, I thought this should be finalized, but I'm getting back an empty array, then that's something more on the dev side that you would consume potentially versus like expect that the client returns back some additional
Yeah.
logic about the internal state that it should be in, that has more
Right.
semantic knowledge.
Yeah, and I think that's why we're discussing this in the context of a style guide as opposed to, you know, a spec or a test that actually is going to validate it. I think this is always going to be a subjective thing, and we kind of just need to come to a collective consensus as to how we advise people to pursue that. I would love to get the automation as close as possible, but there's always going to be some gray area, like you're saying, Zane. Simpson, go ahead. You have your hand up.
Yeah, maybe my 2 cents is it's a mix of both suggestive and an absolute validation. For some of which we already have, right? Provision. For example, let's just take the 3 scenarios you've mentioned in the discussion, which is null, an error, or an empty object. Sorry, empty array or an empty object. Let's consider these 4 cases. We can absolutely say no one should return a null because the downstream client could be anything, and it's easier to process a value or an object rather than a null or a nil or an undefined. So we can straight out say the value should never be null, or it could either be an object or an array. There we can probably standardize, but the distinction between or the validation of the array or an object is easy to do because we already have the spec, and the spec already expects the response to match a type of an array or an object. Sort of we can already implement that. So like we take like 70% uncertainty out of question. Now the actual style guide will come in where we have to say, hey, when do you want to return an error response? When do you want to return an object in an array, or sticking to the bad examples response object or bad output response object? I think that's where our style guide would come in rather than, just generically writing style guide for everything, which will still lead to possible confusions. But I do definitely agree that we have to standardize. For the error code, maybe we can still think about it when we write the standardization for error codes. Probably that would be the base. If we expect an error for a particular method, that should always return an error instead of an empty object. They can, or they can combine both. Now we have an extra description object that can be a stack or a string or an object, whatever it could be. They can return the return format there on top of the error. But I don't want to complicate that there now. At least this way we can solve 75% of the issue by standardizing against the spec and just leaving when to return an error, when to return an object up to the clients to decide by using the style guide.
Okay. That's well
Yeah,
said. Thank you.
I think linter is an awesome idea. Like I've wanted I've wanted one for specs for like a long time. There's a great one in Golang already called vacuum. We can maybe, I don't know if use or like take inspiration from, but that would be a good place to start if we wanted to look at that.
Sorry, you drifted away from the mic there at the end, Shane. You suggested
Right,
vacuum.
so there's
might
a
be one.
there's a Golang project called Vacuum that is like it's an open API linter, but you can use it for other things as well. So that might be a good place to start if we want to do something relatively quickly. Or maybe take it as inspiration, depending on how deep anyone wants to go on a linter.
Cool. Thank you. Okay, got 15 minutes left. I do want to leave some. Tan Nguyen, are you the person that commented on the issue asking to discuss a new EIP?
Oh, yes, that's me.
Great. All right. Thank you for joining. I want to make sure you have some time to talk about what you want to talk about. So let me just, I think there's still a few bullet points in the style guide in the PR section of the agenda. Why don't we pause here and we can discuss those things next week if we don't get enough time after we talk about, what do we got here? ETH, send raw transaction sync method. You want to take it away?
Yeah, thank you. Yeah, and
Yep.
thank you for like letting me talk on this call. Like, we're like proposing like a new RPC for like ETH central transaction sync, like a new RPC method that uh like combines the traditional central transaction and like pulling receipt into a single one to like effectively eliminate the need to pull for transaction receipts. So instead of like sending a transaction and then like repeatedly like checking if it is executed and there is receipt available, like this obviously enables you to get the full result once you submit the transactions. And we tested this and consistently saw like 50% like latency 50% latency like reduction across like different locations. So that is a quick summary of the new RPC. So may I like share my screen to like getting more into the detail?
Yes, you may.
Okay, so oh, why is thing is displayed here? Oh, okay, I need to quit and reopen those. Can I like join back in 30
Okay.
seconds? Yeah, sorry. Just like system settings from Mac. Okay, hi. Okay. So yeah, I think it is.
Yep, we can see your desktop.
Okay. So now can you see the screen?
Yep.
Yeah, so this new EIP is called EIP 7966 to introduce a new like synchronous transaction submission instead of like the current traditional synchronous flow. So as we develop and like a quick summary about me. So I'm Tang. I'm currently a research at Rise Chain. So this EIP is like newly like recently polished and PR to the EIP report by Sam, Hai, and me. Tang. We all both like from Rise Chain. So as we like tested develop Rise and like we optimize for high throughput and low latency, we see that the current the current transaction submission flow is not really like beneficial to users because like it requires at least like 2 round trips for to submit a transaction and retrieve a receipt. This could work for like blockchains with like high block time, like Ethereum with 12 second, or maybe other EVM chains with like 4 or maybe 5 seconds. But like modern chains like Rise, MegaETH, or like base flash blocks like have really low block time and low execution time. So RPC routers become a new bottleneck and becomes like the dominant latency factor from end to end, like dominating the end to end time from transaction submission to receipt retrieving. And many like users like expect like near instant feedbacks on these modern chains once they submit transactions. As here we can see like the traditional like transaction submission and like receipt pooling. This inefficiencies like may is like, or like can completely be like eliminatable in like modern chains like Rise. So we came up with we not actually came up, but we implemented a solution to this with like the solution is pretty simple with like less than 20 lines of code that combines both the traditional like send draw transaction and the pooling receipt into the RPC handler on the node side, and it has like huge impact on the times that we can save for the users on like waiting for the receipts. So as you can see that the client or users have to make like at least 2 RPC core, but like after the transaction is sent, it like mostly executed, and the receipt is like nearly or instantly available after it is received from the sequencer or like block producer side. This is because like modern chains like Rise or Mega like have really high throughput, and their sequencer or block producers are optimized for processing high like throughput and high load of transactions. So this is the wasted time if we use the traditional async method. So if we switch to the newly introduced like method, it can be like this time is can be saved, and user can receive feedback from their transaction almost like immediately after like one RPC round trip. We also like have this running around test nest like for a few months, and we performed a simple benchmark with like 4 different like geographic locations that have like different like base like RPC round trip time to the node. So this is measured by taking the median of like 200 sequential ETH get block number, RPC core, to measure the median time. And we measure the total time it takes to submit a transaction and when the client can retrieve the receipt. So the newly introduced method like provides a consistent like performance with its latency is as low as a single RPC time. So this is at like this is expected because like we only made one RPC core, and the processing power at the node side is very small. Compared it against the async or the traditional flow, the async flow has like almost like 2 times more latency than the sync method. So we can see like over like 50% like improvement in latency here. We can get this implemented. So the EIP is created, and API is open in GitHub. right here, we are like asking for comments and suggestions. We also have like enclose a sample implementation to the EIP, and the discussion link on Ethereum magicians is also included. The reason why we polished this into an EIP is that because like whenever we introduce a new RPC, and this is RPCs like can benefit like most of the user and developers, but for user to like fully utilize this, we also need to like implement some sort of like wallets, a new wallet or something like that. But if it gets like implemented into like different like clients implementations or wallets or libraries, then it is like much easier for like other chains. I I heard that like other chains, they like don't have the this like type of RPC, but they thought of it but haven't had time to implement it. So if we can like standardize this kind of RPC and make it like fully upstream to the client implementations, like rollups or like latency optimized chains can hugely benefit from this. And yeah, I think that's it from my side.
Thank you. Would you mind posting a link or a PDF or something for these slides? I'd love to run these by people at Infura to get their opinions on it, if that's something you'd be okay with.
Yeah, that would be like really cool. I will send the slide in the Discord.
Great.
Yeah,
Cool.
and would love to have like more comments from like node implementers or like wallet or like library maintainers or something like that. I think would be very cool. Have fun first. Yeah.
Zane, go ahead.
Yeah, cool. Thanks for the presentation. I was kind of curious what this kind of looks like, just even say on like Rise Network. So if you had like 1 second block times and you have RPC requests that are like, let's say in the speed of 240 milliseconds, then the total round trip time is going to be still dominated by that 1 second block time. Is that correct? Or
Yeah, that's correct. So like when I analyze the total like latency, there are like actually like 3 or 4 like main factors. So the first one is like the time it takes to propagate a transaction from the client to the full node and to the block producers. But like for like in general, like rollups, they are like often advertised they're like maybe sequencer, not the sequencer endpoint, but like the sequencer's replica endpoint. So it is basically like very close to the block producers at that point. But we can see that this number is like there's nothing we can do about this number because like uh we like the things we can do about this is like to have our clients like physically like be close to the block producer. So that's why we set that number to be the baseline for our like benchmark regarding the block time. So uh yeah, uh you're right that the dominating factor is still the block time, but uh, as like many chains are optimized for latency, they have like some sort of like sub block sub blocks. So like right in Rise we have like shreds, and Mega if they have like mini blocks, or like base they have like flash blocks. So they are all like sub-second like block times. So they all like have like sub-second block time. So as long as we can like reduce the block time into like maybe like this obviously is like recommended for like chains that have like less than 100 millisecond block time or something like that, and they can all like benefit from this RPC.
and the proposal would be that like for like Geth or mainnet, that the RPC call implementation would be optional. Because like otherwise, if users were to hit the synchronous client, it seems like a lot of like lingering connection load.
Yeah, yeah, sure. Like, yeah, sure. Like for Ethereum, like for example, like it is like fully optional for Ethereum and other chains. So this is like if you enable this and you like your network has like really low time, so user can really benefit from this. But yeah, it is fully like optional for full nodes to whether like whether they should enable this or not.
Cool. Thanks.
All right. And that brings us to time. Thank you, everyone. Very productive meeting. Stay tuned in the Discord. See you again in 2 weeks. I'll post a new agenda where we can resume with some of the points that we didn't have time to get to this week, as well as there should be an AI summary that comes out and maybe some action items. So,
Yeah,
have fun,
thank you
everybody.
for bye.
All right, see you on the internet.